Black holes stand as one of the most mysterious and intriguing phenomena in the universe. Three researchers for their studies on black holes received the 2020 Nobel Prize in Physics. Half of the prize went to Reinhard Genzel and Andrea Gage for finding a supermassive compact object at the center of the Milky Way, while Roger Penrose received the other half for demonstrating that black hole development is a reliable prediction of Einstein's general theory of relativity. A black hole is a region in space where the gravitational pull is so intense that nothing, not even light, can escape from it. This happens when a massive star undergoes gravitational collapse at the end of its life cycle and can happen when a star is dying. Because no light can get out, people can't see black holes, they are invisible. Here are some key characteristics of black holes. To telescopes, black holes appear to be invisible because they neither reflect nor emit light. A black hole's accretion disk is the ring of gas and dust that surrounds it. All visible light, including X-rays, is emitted by the ring. Stars can revolve in a specific direction around a supermassive black hole because to its strong gravity. The supermassive black hole at the center of a blazar which displays the black hole surrounded by a darker ring of gas and dust and a brighter accretion disk. 2. Formation of black hole. Star formation. Black holes originate from massive stars with a mass several times greater than that of the Sun. These stars form from clouds of gas and dust through gravitational contraction. As the star contracts, it heats up and initiates nuclear fusion in its core, which generates the energy that keeps the star shining. Nuclear fusion. Throughout its life, a massive star undergoes various stages of nuclear fusion, converting hydrogen into helium and progressively heavier elements. As the star exhausts its nuclear fuel, it begins to fuse heavier elements in its core, leading to the formation of progressively denser layers of elements. Supernova explosion. The collapse of the star's core triggers a cataclysmic explosion known as a supernova. The outer layers of the star are violently expelled into space, while the core collapses further. The energy released during the supernova explosion can briefly outshine entire galaxies. 3. Anatomy of black hole. These are made of the same material, ranging in mass from stellar mass black holes that are a few times as big as the Sun to supermassive black holes which are billions of times heavier. Black holes possess only three properties: mass, spin and electrical charge. An accretion disk, singularity, Doppler beaming, photon square, corona, event horizon, and event horizon shadow are the various components of a black hole. Accretion disk. The accretion disk is the heated disk of gas surrounding a black hole that serves as the primary light source for the gigantic cosmic entity. Black holes can expand by joining forces with other black holes. When two stars are partnered, a stellar mass black hole expands by absorbing mass and gas from the companion star. A black hole loses its accretion disk and becomes isolated, making it challenging to locate and analyze once it has ingested all of the matter in its surroundings. Singularity. The theoretical point at the very center of a black hole where matter is crushed to infinite density, as predicted by the general theory of relativity, is called singularity, and it is the final destination of anything talking into the event horizon of a black hole. Corona. The corona is a chaotic, billion-degree cloud that lies both above and below the black hole's surrounding disk. Particles are accelerated to nearly the speed of light in the black hole's corona, which emits X-rays with energy far higher than those coming from the accretion disk. Event horizon. The boundary of a black hole where the velocity needed to escape the structure must be more than the speed of light is called the event horizon. Even light cannot escape the event horizon. Therefore, the event horizon is the reason why a black hole is black. Anything that passes into the event horizon is doomed to stay inside it, even light. Since the accretion disk does not enter the event horizon, it reflects light, making it possible for astronomers to study black holes. Event horizon shadow. The event horizon shadow is a zone roughly twice as big as the event horizon of a black hole. The combined effect of the event horizon capturing light falling into it, and refraction of light coming from the accretion disk due to the gravitational lensing effect created by a black hole, forms the event horizon shadow. Doppler beaming. It is an effect that causes the accretion disk to brighten where it spins towards Earth and to darken where it spins away. The accretion disk is spinning so quickly in close proximity to the black hole that the general theory of relativity starts to show its effects. The accretion disk's rotating portion that faces Earth reflects light that gets brighter and bluer, while the portion that faces away from us reflects light that gets redder and dimmer. Photon sphere. The photon sphere is made up of the thin light rings that emerge at the border of the shadow cast by the event horizon. These narrow bands of light, which are several severely warped pictures of the accretion disk, are visible from all viewing angles. Before it is visible to observers on Earth, light from the accretion disk circles the black hole several times once it reaches the photon sphere. The rings get thinner and less visible the closer they get to the black hole. Black hole particle jets. The diagram depicts the formation of a dense accretion disk surrounding a black hole as a result of the destruction of a star that strayed too near to the enormous object. A dense, chaotic disk of hot gas was created by star debris falling into the black hole. A thin jet of fast-moving particles was created as matter that approached the accretion disk was diverted in the other direction. These black hole particle jets can extend hundreds of thousands of light-years.